A rate of change is always with reference to time. So it's always what you get when you differentiate with respect to time. So d by dt is always going to have dt on the bottom. And we're going to look at connected rates of change today, which is just a way of applying the chain rule. Now the chain rule, you should remember, is that dy by dx, we can take dy by dx and split it as if it was two fractions and introduce a new variable. The standard one for the quotation of the chain rule is du. So this is the pattern we're going to use for our connected rates of change. So let's look at what we've got. So we're given an area of a circle is pi r squared, and we're told that dr by dt equals 5, and we're being asked to find dA by dt. So we're going to use our chain rule trick that we can split our dA and our dt and introduce a new variable, and the other variable we have in the question is dr. Now we already know dr by dt, we've been told it's 5. dA by dr, well, here we've got a formula for a in terms of r, so if we differentiate with respect to r, we get dA by dr, so we can put in our information. So dA by dr is 2 pi r, and dr by dt is 5. So dA by dt is 10 pi r, and we're asked for it at r equals 3. So dA by dt is 10 pi times 3, or 30 pi. So second example looks a little bit harder, but is following exactly the same things. So we're given volume of a hemisphere, half of 4/3 pi r cubed, and the total surface area is the circle on the bottom plus half the surface area of a sphere, which gives us a total of 3 pi r squared. We're being asked to find the rate of increase of the surface area, so ds by dt. So we can split our ds by dt and introduce a new variable. Well, obviously we know something about v, so if we introduce v, we then know dv by dt is 6, but we don't know ds by dv, and we don't have a formula for s and v. So we're going to repeat the process on ds by dv by introducing another variable that we do have, which is r. ds by dr, dr by dv, and then dv by dt. Because if we imagine these are fractions, dr cancels with dr, dv cancels with dv, and we're left with ds by dt, which is what we want. So dv by dt we know is 6. ds by dr, well, we've got s, so we can find ds by dr. Just by differentiating, we get 6 pi r. dr by dv, well, we don't have r in terms of v, but we do have v in terms of r. So we can work out dv by dr, which is 2 pi r squared. And therefore dr by dv is just the reciprocal, 1 over 2 pi r squared. So let's put all those pieces of information in. ds by dt equals ds by dr, which is 6 pi r, dr by dv, which is 1 over 2 pi r squared, and dv by dt, which is 6. If we tidy all that up, we get 18 over r. And we're just being asked for it at any time. We're not given a specific time, or a specific radius, so we're just going to leave it as 18 over r.